Hey, hello guys. Good morning. So, this is Sanjay here. It's been so long since I uploaded videos on YouTube. I think it's good to be back again. So, I thought we'll just see today some concepts of probability and slowly move into distributions part, which is, I think, it's not present in the syllabus of class 11th or 12th. I think it's engineering mathematics, or I think only one distribution, binomial distribution, you have studied in 11th or 12th. I just go with the flow with the distributions part, okay? Because it contains lots of mathematics, the calculus part here. So I'm very interested in calculus. So I thought we'll just start with this today. Good morning. We'll just start with what is called a random variable. Okay. So before knowing what is a random variable, you should have known all the basic concepts of probability, right? If you want that also, I'll put some other video. The basic concept of probability, like basic formula and the addition principle, the P of A union B, that one, and whatnot, the conditional probability, the Bayes theorem, the total probability, etc., etc. So after all this, you slowly move into random variables. I'll just write it as RV. So random variable is nothing, okay? It acts like a function, but its name is variable. So I'll tell you with one example, okay? If you toss, two coins, this is the event, okay? And now tell me what possible outcomes you can get. It can be two heads, can be one head and one tail, can be one tail and one head, or it can be both tails. This is what, remember, this is called sample space, SS. Okay. Now the probability of getting one head, if you take, that will be what, 2 by 4, correct? So the probability part, so similarly we're going to extend that to as a concept called random variable. Now I'm just telling, okay, let x be the number of heads you get while tossing two coins, okay? Now what are the possible number of heads you can get? You can get either zero heads, or you can get one head alone, or you can get two heads, right? So the probability of getting zero heads is what, this is the only part, right? This tt, that's where you get zero heads. So the probability of that will be 1 by 4, because length of sample space is 4. And the probability of getting one head is what, there are two possibilities. So you can get 2 by 4, it can be ht or th. And probability of getting two heads is what, again this is one possibility, so you can do 1 by 4, okay? So this part, whatever you have done just now, is called a random variable. So you can take random variable as anything. It can be number of heads, or it can be number of tails, or maybe getting number of twos in rolling two dice. Anything is fine, okay? So this random variable is nothing much big deal. There's no big concept out of it, but it's just a basic concept that you have to know before entering distributions, okay? Now random variable is done, right? So extending this random variables concept, we'll see one more concept called PMF, okay? It's called probability mass function, okay? The name tells function, which means there should be some input, there should be some output. In fact, whatever we have done is this part, right? This is called PMF, okay? I'll just tell you what. Okay, so probability mass function is a distribution. It is a function that takes in the values of a random variable and gives out to the probability. So in the coin tossing example, the possible values of the random variable, let's say again the random variable x is number of heads, the possible values of x will be 0, sorry, yeah, so 0, 1 and 2, right? So in some books they would directly write f of x, okay? Or in some books they also write f of x is equal to x, both are same, okay? So f of x, both are not exactly same, but the represent for the representation purposes, okay? So every time you need not write x is equal to x, right? So that's why they put f of capital X. But f of 0, there's no meaning of f of 0, okay? Because the input is 0, and the input is assigned to this random variable, so you write x is equal to 0. Understood? Nothing of big deal. We just continue the concept. So small x value is 0, 1 and 2, and the corresponding distribution, which is nothing but the probability mass function, whatever I told you just now, will be small f of random variable a capital X is equal to x. So small f of x equal to 0, small f of x equal to 1, small f of x equal to 2. What is the probability that you get, what is the probability that random variable will be 0, which is nothing but the 0 heads we have written here, 1 by 4. Okay, so that will be written here. And one more thing, here this is 2 by 4, this is the probability mass function base, that's all. Okay, just a function, the distribution, that's all. Simple. Okay, this is a probability mass function. You get different PMFs for different distributions. Binomial has some other PMF, Poisson has some other PMF. We'll see those. Okay, don't worry. Now, when you extend this again, this concept to something called a CDF, which is nothing but cumulative distribution function. The word tells cumulative. So cumulatively, you add the probabilities. So what are the possible values of a small x? 0, 1, and 2. And now the probabilities are nothing but 1 by 4, 2 by 4, and 1 by 4 again. So the cumulative distribution, this is represented by f of like this. Okay, now this is represented by capital F of x. Okay, so I'm telling you why there's a difference in representing this. Okay, so capital F of x, which is nothing but, let's say first we plug in the value 0. What is capital F of 0? It's nothing but the same, this corresponding value will come. Now what is capital F of 1? You add these both. Okay, you add these both. What is the answer? 3 by 4. Now what is this capital F of 2? You add everything over here and write as 1. Understood? Cumulatively you are adding the probabilities. So if you want to write this bit mathematically, you can write, f of x is equal to sigma. You add the probabilities, right? So f of x is equal to x. You start from some random 0 until x. So if you want to calculate f of 2, you will put 0 to 2. F of x is equal to 2. You are not just calculating the probability that x equal to 2, you are calculating the cumulative probabilities till x equal to 2. So it can be written as this sigma, but it is okay, represented as f of do sigma, no, just do f of capital X less than equal to x. So what will come? So f of, here it is nothing but f of capital X is less than 2, correct? So f of x equal to 0 is possible, plus y plus, because it is sigma, 1 is possible, and 2 is also possible. So we add everything and put 1, right? 1 by 4 plus 2 by 4 plus 1 by 4 is 1. So this is the concept of CDF. Okay, so cumulatively you are adding the probabilities, and in books, if you see, they would have given some properties of PMF and CDF. It's not needed that much, but just know it. Okay, since it is probability, it cannot go beyond 0 or beyond 1 also. So it is always lie between 1, and if you add all the uh, possible probabilities that you can get in a experiment, you will get 1, of course, correct? We got 1 here also, right? So it's not x here. Okay, when you put x, it will become CDF, because that x is you are deciding that x. Now 0 to all possible n. Okay, so if you fix it as x, you can stop till 1 itself in this question, so it will not get 1 here. So the representation is very important. Okay, now if you see the capital F of x, the property, this is also applicable. Like, obviously it did not go beyond 1, right, in the capital F of x, so that is applicable. And when you calculate the CDF, your last CDF when you're calculating will always be 1, this part, right? If it's not 1, you're doing some mistake. Okay, so this is not round properly. Okay, so this will always be 1. So understood the concept of random variable, PMF, and CDF. Now before moving to distributions, I'll tell you one more concept called mean of a random variable. So this is represented by E, which is nothing but expectation. The same mean only. Okay, of a random variable x is given by sigma x into f of x. That's all. Now understand why it is small x instead of capital X. Simple. Since you are doing sigma, okay, there are, you know, there are different possible values of x, right? See, that's what. Do not confuse the notation, capital S and small x, okay? When you write just small x, it is nothing but 0, 1, and 2. When you put it as capital X, it is nothing but x equal to 0, x equal to 1, x equal to 2. That's all. Both are similar, okay? When you I'm writing small x here because when we will see the calculating mean and variance of binomial distribution, Poisson distribution. There you will see that when you put small x, it will be easy for you to calculate with the PMF, because your PMF will look something like this. It will be something like NCX P power x for a binomial distribution, telling n minus x. You can see small x all over here. When you put capital X here, it will be confusion. That's why I'm writing small x. Okay, so don't be confused. Okay, so this is the sigma. This is a summation. Okay, so you can tell from x equal to 0 till n. All possible values you will take and do the mean. And similarly, in generally, you know what is mean, right? In mean of all n numbers, let's say up to 10. What is the mean of this? 1 plus 2 plus 3, right? 10 by 2. 10 by, sorry, 10, correct. This is the mean. What is this? 55, I think, so 55.5. So this is mean, but in case of distributions, you calculate the mean like this, okay? So similarly, variance can also be calculated. Variance is nothing but, in the case mean is represented by mu, variance is represented by sigma square, okay, not sigma. And when you calculate a standard deviation, this is a statistics concept, but when you come to engineering or beyond that, statistics and probability, go at par of the same. There are different concepts in statistics. There are different tests, okay, but I'm just telling they get common things at sometimes, okay. Standard deviation is nothing but sigma. So sigma square can be found out using the formula E of, actually the formula will be this one. Can you understand this? Variance is nothing but the deviation from the mean. Okay, standard deviation and variance means the same, but variance will give you the just it is just because you're doing square, right? So it will be easy for the calculation. That's why. But the meaning, the intuition behind variance and standard deviation is same. So if you say this is the curve, this is a distribution, and your mean will be somewhere here, and now the sigma, the standard deviation or the variance, this will be somewhere here. There can be two standard deviation plus or minus, because you are taking the root out of it, right? So can you see this deviation, this mu from the deviation from the mean is called the standard deviation. So this is the concept behind that. So you're doing this x minus, understood? That's why you're subtracting the mean from it, so in order to see the difference. So when you expand this, you will get e of x square minus mu square. Okay, it happens when you expand it and see, it will come. If you want to just tell, I'll put some other video for that. Okay, so this is nothing but the formula for variance, and you do sigma square, you get sigma. That's all. That is variance square. So these formulas you just remember for now. Okay, and e of x square is nothing but the same thing, whatever you did here, but instead of x here, put x square. That's all. I'll tell you how to calculate those in the distributions, okay? But this is the formula. Sorry, guys. This is the formula you must remember. Okay. So we'll just move on to distributions in the next video, but I'll just revise once. So whatever you studied till now, the probability that in the basic class you studied, basic probability, etc., etc., the addition theorem, etc. So now we are moving to random variables, where we saw the tossing of two coins with the number of heads as a random variable, and the distribution of this is called a PMF, and cumulatively adding the distributions, the probabilities, is called CDF. And we saw how to expand this CDF, and we saw the representation. This representation is very important. Okay, when you solve problems, we'll solve problems. Okay, you can understand at that time, and the properties we saw, and now slowly we saw mean, variance, and deviation also. That's easy. Okay, now this is the concept you want to know before doing the math. Here we hardly did any math, we just explain the theory and concept behind it. So now we'll move on to distributions in the next video. So until then, just keep revising, keep studying. Thank you guys, bye.